Hi, welcome to my YouTube channel. I am online Skype tutor Engr.Muhammad Rizwan. In this video, we show that limit x approaches to 0, x into sine of 1 upon x is equal to 0. Now we start our solution. As we know that this is the angle of trigonometric function sine. So this angle cannot be undefined. This is always defined. So if we put 0 value, then we get undefined. So we can put all real numbers, but we cannot put 0 value. So we say that domain of sine of 1 upon x is equal to the set of all real number except 0. So its range is from -1 to 1, which can be written as absolute value of sine of 1 upon x less than equal to x. Here it is written that we can take all real numbers except 0. We cannot take value x is equal to 0. We can also write this as x is not equal to 0. As 0 is not included, so there may be values as greater positive values and negative values. So first we take positive values if x greater than 0. We find the relationship between absolute value of x into sine 1 upon x and x. We put some positive real numbers and see the relationship between this, and after on the basis of these some values we conclude that for all positive real numbers this relation will also be true. Now see that we put 1, we get answer 0.01745 less than 1. Then we get answer, and this answer is also less than 1. So we can say that there is this value and x has relation of less than. Now we put 30 and we get answer 0.01745, which is also less than x. So we say that this value is less than 30. Now we put 1 upon 90, x is equal to 1 upon 90. Here is the x value. Now this 90 will move here. Sine 90 is equal to 1. 1 will be multiplied to this. 1 multiplied to 1 upon 90, we get 1 upon 90. So positive number absolute value is also this number. So this is the absolute value of x into sine 1 upon x, which is equal to the x. Now there is a equal relation. So on the basis of putting some values, some positive numbers, we can conclude that absolute value of x into sine of 1 upon x less than equal to x. We can write simultaneous inequality as this. This is the other form of this. If we have given x absolute value of x less than equal to 0, if and only if minus c less than equal to x, x less than equal to c. Now we check the behavior for negative real numbers. We put some negative real numbers, and we find the relationship between this and this. as absolute value, answer of absolute value is always positive. So we want to find the relationship between two same type of quantity. This is a positive quantity, then we should try to find the relationship between positive quantity, as x is a negative. So for making it positive we multiply minus. So in this way this is also positive. We want to find the relationship between two positive quantities. We put x is equal to minus 1. So after solving, this minus can be written here, and this minus can move here, as we know the formula sine minus theta is equal to minus sine theta. We multiply minus to minus, we get answer positive. Sine 1 is equal to 0.01745, which is also less than minus x value, minus x. Minus into minus 1 is equal to 1, which is the value of minus x. Now we can write there is a this value, and minus x value has less than relation. Now we put minus value minus 5, and this minus can be written here, and by the formula we can move this minus here, and minus multiplied by minus will be positive. So we find this value, which is equal to 0.01745, which is less than minus x value. Minus x value is 5. So there is a relationship is less than relation. This quantity is less than the minus x. Now we put x value as minus 1 upon 90. Here this is, we put x value, here we put x value, and this 90 will move here, and this minus can be written here. So by the formula we can write minus here, this minus and this minus will be multiplied, and we get positive. So sine 90 is equal to 1. 1 multiplied to 1 upon 90, answer will be 1 upon 90, and absolute value of 1 upon 90 is also equal to 1 upon 90. So this is the absolute value of x into sine of 1 upon x, which is equal to 1 upon 90, and minus x is also, minus x value is also 1 upon 90. Now there is an equal relationship, so we can say that this value is equal to the minus x. We conclude that absolute value of x into sine 1 upon x less than equal to minus x. Now we can write this inequality in simultaneous inequality as by using this formula. By writing x minus multiplied by minus x sine 1 upon x less than equal to minus x. This is our second simultaneous inequality. Now we write our previous simultaneous inequalities A and B. For positive real numbers we get simultaneous inequality as, and for negative real numbers we get simultaneous inequality as. Here these signs are same, this middle function is also same. We want to write a general simultaneous inequality. Instead of writing two simultaneous inequalities, we make one simultaneous inequality which may be true for both positive real numbers and negative real numbers. These are smaller functions. Here this smaller function is minus and here this smaller function is x. Both are different. Here this is a greater function and this is a greater function. Both functions are different. One is in inequality A, here x is positive, here it is negative, minus x. So by definition of absolute value of x, we know that absolute value of x is equal to x when x is greater than 0. As absolute value is a distance from 0. If we have a positive number, then its distance means absolute value is equal to 2. As we know that distance is always positive, minus 3, then its absolute value means distance is always positive. We can make this distance positive by multiplying number to minus. So in this way, as when x is negative, we want to make it positive, then we multiply it with negative. So absolute value of minus number is this. If we multiply both sides by minus, here we multiply by minus, and this will also be multiplied by minus, and here is minus x and we multiply it with minus into minus x. So we get minus into absolute value of x is equal to minus x and x. For positive value we get minus x and for negative value we get x. Now we make the general. When for positive value here is minus x and for negative value here is positive x. So in general simultaneous inequality we can write this, because for positive real numbers it is minus and for negative real number it is positive. So in general inequality we write smaller function as, which is true for both positive real numbers and negative real numbers. Now we see the behavior of larger greater function. It is when x is greater than 0 it is x. When x is less than 0 it is minus x. So we can write this. This is according to the definition of absolute value of x. X greater than 0, here is x. X is less than 0 means x is negative, then we get minus. So in general simultaneous inequality we can write greater function. We can write greater function as x, absolute value of x. So this is our general simultaneous inequality, which is true for both positive and negative real numbers. Now we apply limit x approaches to 0 to every expression in C. Limit x approaches to 0 and limit x approaches to 0, limit x approaches to 0. Here is the limit of smaller function. This is the limit of greater function. By squeeze theorem we know that if the limit of this smaller function and this greater function becomes equal, then we can write the limit of middle function will also be equal to the smaller function or the limit of greater function. So limit of smaller function minus into absolute value of x is also equal to 0. So limit x approaches to 0, absolute value of x is equal to 0. So both functions smaller and greater function limit is equal to 0. So by squeeze theorem we can write limit of middle function is also equal to 0, because the limit of smaller function and greater function is equal and its value is 0. So this 0 will be the value of middle function. This is our result. Thanks for watching my video. If you have any confusion, you can contact me on Facebook page, you can contact me on Skype, you can contact me on my WhatsApp number. You can also comment on video. I will try to solve your problem. I will try to help you. Thanks.